Hark, it's Duraspark. Okay, stupid remark out of the way. Let's get down to business. So, we're going to do a comprehensive and thorough explanation of the Ford Duraspark conversion for a 65-66 Mustang. Most Fords are pretty much identical. I use the 65-66 because I have very detailed, easy to follow, color-coded schematics, which will show and demonstrate just how easy a conversion it is. Now, people have had historic problems with Duraspark conversions because they will kill the ignition module or kill the coil or both. So we'll do the math and science on what is causing that, what the limits are, and how to avoid it. In so doing, we're going to debunk the Duraspark myths, go through common mistakes, including fault isolation and troubleshooting, including the bane of a lot of Ford's distributor drive gear compatibility and failures. We'll go through that and we'll have summary and recommendations. Check out the intro screen for a whole bunch of parts and reference sources. Okay, nope, this is not just some YouTube video for clickbait. I actually ran Duraspark and I loved it. So before we get into the specific details, let's take a trip down memory lane. 1989, went down to the public library and looked in those big 3-inch thick Chilton maintenance manuals, found the Duraspark wire diagrams, got these parts together, an Accel blueprint distributor for those of you that remember those, 9207. It's obsolete now. Got a Wells Amco solid state blue grommet module. Now, I went under the dash of my 65 Mustang and found the pink ballast resistance wiring coming off the ignition switch. It's a bullet connector. Popped off the bullet connector. I made a little bypass harness so that I could send 12 volts directly to the module. You'll see that later in the schematics. And that harness also allowed the voltage to go through the pink ballast resistance wire to an Accel 8140, had to be a chrome coil, 1.4 ohm primary resistance. I opened up the spark plug gap a little bit. How did it work? Great. I mean, it really worked well. Never had a problem with module failure or anything. So I used that for about a year. It ran better, started better, accelerated better. I was pleased with it. So I decided, okay, I've got some performance upgrades. I'm going to go to this big Accel super coil. We'll see that later in the presentation. Some of you remember this thing. This thing was a tank. That had a lot less primary resistance, which we're going to talk about. I used a wider 40,000 spark plug gap. The performance was even better, especially at cold startup and high RPM. I drove this car every day. Here I am, handsome guy, I know. Anyway, there's me at Sears Point Raceway in California. Some of you are going, oh my God, Sears Point Raceway. That's right, Napa Valley. There I am, guy with a stock 351 Cleveland 2-barrel Grandma's Torino. I think it ran like a 17. Anyway, guys, I used these Duraspark probably for a little more than 3 years. I never had a module failure or overheated and failed a coil. Worked great. So let's get into the specifics. Okay, I'm not going to read the history of Duraspark 1 and 2 word for word. I know, thank God. So this is some interesting history which I got from various sources. Some of you are going to read this and say, whoa, whoa, whoa. What I really need is this red grommet variable dwell Duraspark module. I don't blame you for thinking that. You're not going to find one. Don't bother trying. If you had a brand new solid state red grommet Duraspark 1 module and you wanted to get it working, that would probably be a very cool nostalgic setup. But we won't get into doing that because they're really not available. Let's get going. Okay, none of this is really going to make sense if we don't talk about the ballast resistance system, because the Duraspark relies on a ballast resistance system. So With Fords of the 60s and 80s, the ballast resistance system was composed of two parts. It's this pink wire, which is under the dash, not under the hood. This is an MPD replacement. You can actually see the pink wire, and you can see the bullet connector, which I mentioned earlier. You can see the resistance value. You combine them, the 1.35 and the coil resistance. That's going to drop voltage to the positive side of the coil to about 7 to 8 volts. Now the nichrome wire, that's nickel chrome. The nichrome resistance wire is very tough, and it's really not going to wear out to where the resistance value changes. People will screw around with them. They will cut and splice into them, and who knows what the resistance value is after that. Now, when you see these coils, here's a reproduction Autolite yellow top coil. They use this phraseology, used with external resistor. Okay, they're not talking about a ballast resistor. They're talking about a resistance wire. So let's just get that cleared up. Let's move on. Okay, now we're going to get into some of the math. Chevy guys do what the blogosphere tells them to do, and Ford guys go figure out how things work and do it with math and science. That's why we're here. Okay, so the original Duraspark devices, they were point replacement devices. So they were intended to be used with a ballast resistance system. So we're going to talk about total system amperage that the ballast resistance system will generate and how the Duraspark module needs to fit within those limits. So let's do a little math here. So it's just really simple Ohm's law, which is arithmetic. Okay, so what we need to do is compute the operating system amperage. Using the factory resistance wire 135 with a factory coil of 1.47 ohm primary resistance results in 2.82 combined resistance. Okay, that's the total ballast resistance value. Now that's going to drop voltage to the positive side of the coil to about 7 to 8 volts. Let's assume 7.5 volts for the purposes of calculation. So the system amperage that the points condenser is exposed to, using Ohm's law here, is going to be about 2.7 amps. Now, various sources that I checked out, the maximum amount of coil primary current to be switched by points is about 4 amps. Above 4 amps, you're going to get advanced point wear and burnout, including the condenser. In fact, the condenser, if you really screw around with like getting rid of the resistance wire or getting rid of the resistance wire and using like a 0.6 ohm coil, and you're using points condenser's probably going to quit on you first. That will strand you on the side of the road. Now, the system wattage, which is power, which is heat, is spread over the coil and the resistance wire. Now, to simplify the conversation throughout this presentation, system wattage, I'm just going to refer to it as coil wattage. Yes, I just mentioned it's spread out over the coil and the wire, so you'll see me just say coil wattage. Okay, so what is it for the factory setup? So using Ohm's law for power in watts, you're going to get about 20 watts. So what if I have a lot more than that? Well, if you have a lot of coil wattage, you're going to overheat and damage the coil. And I think that's what Cool and the gang were talking about. Now, for the total system amperage of 2.7 amps and 20 watts of the coil, those are going to be the baseline values that we are going to compare to Duraspark II values. I'm not trying to say they need to be identical, but keep in mind the Duraspark modules were point replacement devices. So the original Durasparks were designed to be very close to that. We will get into that in detail. Okay, let's talk about Duraspark module maximum system amperage. And you exceed that, and that's what kills them. So we'll talk about that, but let's look at the schematic first. So this is not the schematic that you will use to wire this up, you could, but I've got far more detailed schematic for 65, 66 Mustang later. Some of you already jumped ahead to that, but this is the one you'll get from maintenance manual. Duraspark is full 12 volts to the red wire. Now you can see here it is before the resistance wire. So people who will wire up Duraspark modules and grab the power after the resistance wire, you will under voltage the module. It may start and run. It may quit. We'll have that in the troubleshooting later. But as you can see, it is full voltage. You can see that the resistance wire was maintained. Again, the Duraspark module was a points and condenser replacement device. It still used a ballast resistance system. So what was the original Duraspark amperage? So using some of the previous math we discussed with the combined resistance, we just use Ohm's law to figure out, I'm going to use 8 volts at the coil here. It's a little on the high side, but it's conservative. So what we're going to see for Ohm's law is about 3.5 amps. I will talk about how to properly measure coil voltage, but 3.5 amps. Now, Ford never published the maximum Duraspark module system amperage limit. Why would they? So nobody really knows what it is, but we know that it was a points replacement device. So let's round up a little bit here and say it's probably 4 amps max. Now, the GM HEI module, which was that tiny little thing, that actually did have a published system rating of about 5 amps. I think that the Duraspark modules, if we go back in time, the Duraspark modules were more robust than the GM HEI modules, but this is not a comparison. Now, if we exceed that Duraspark maximum system amperage, the module may work for a while, but it's probably eventually going to fail. The modern Duraspark solid state modules likely have a much higher system amperage limit. That's not published either. So some of you are rolling your eyes saying, who cares then? Well, we're not going to run experiments and pump 17 amps through a Duraspark module and see if it works. So the rest of the presentation will focus on how to keep the Duraspark modules for conversions in this 5 to 6 amp range. Actually, the coils in here will be slightly below 5, so you should be okay. We'll get more into modern Duraspark modules. Here we go. Okay, so let's talk about carry here, or let's talk about some Duraspark myths. So I kind of boiled this down to blogosphere complaints about Duraspark failures and how people aren't going to use them anymore. So somebody found some online instructions and converted. They burnt up 3 O'Reilly made in China Duraspark modules, and then they said Duraspark design is junk. I'm going to get an MSD. No, that's not what happened. What they probably did was they used incorrect primary resistance coil, or they deleted or bypassed the factory pink resistance wire. Okay, that's myth 1. 2, I've seen this several times. NOS Duraspark modules are the only ones to use. Absolutely not correct. Although the original Duraspark modules were indeed reliable units, it's not unusual to see one that's lasted for 20 years. And you'll see that on YouTube videos where guys will get some old clunker running. That's, some old 80s Ford. And it starts right up. So that doesn't mean that they're a superior unit. What it really means is that car's coil and ballast resistance configuration was not screwed around with, so it worked. So as you can see here, if you screw around with primary resistance, the coil and or the resistance wire, you jack up the system amperage. And this is a blue streak parts counter picture. The original Ford NOS modules had this ceramic resistor So what I found was these things would break, the thing would stop, the unit would cool down, close the termination, maybe it would start again. Solid state modules don't use this NOS design. Don't use an NOS dirt. Don't go on eBay and spend $100 on an 80s Duraspark module. It's not worth it. So that gets into aftermarket Duraspark modules. People think they're all made in China, they're garbage. Not correct. There's a Blue Streak one, that's with this picture, but the really nice one is the Made in USA Ford DY893 module. Let's talk about that some more here. But let's go through a couple truths. You could see the Ford module here. Now, the aftermarket Duraspark module to use is this Made in USA, sold by Ford, 100% solid state. This has been out there for a long time. This is the one to get. You'll see lots of ratings on this. You can get it at Summit, Amazon. Be careful you don't get a counterfeit one. So might be a little careful on Amazon. Get it from a known good supplier. Now, are there El Cheapo $20 aftermarket made in China Duraspark modules? Yeah, get one and throw it in the trunk. As I mentioned earlier, we do not know what the system amperage limit is for this Ford module is, but it's solid state. It's going to be a lot higher than the 4 amp rounded up estimate of the original Duraspark modules. We don't know how high it is, but it's going to be a lot higher. Let's just say 5 or 6. Now, let's talk a little bit about this Duraspark module, get this out of the way, and I won't talk about it again. So the Duraspark II modules, the blue gromets, are not variable dwell. So some ignition nerds out there are like, well, the GM is, so the GM is superior. Okay, variable dwell is superior, especially for high RPM operation. The GM HEIs, especially the early ones, were nothing to brag about. So anyway, won't go through all these points, but at low RPM, when you don't have variable dwell, you actually get too much dwell, but millions and millions of cars did that, so, and they drove around for decades. High RPM, you don't get enough coil charging without variable dwell, so you might get some misfires if you're trying to drag race. So the Duraspark ignition system, it'll work for drag racing. Thousands of people have gone drag racing with Duraspark modules. I did. I actually don't recall getting any misfires, but I was probably not exceeding 5,500 RPM. By the time I got up to 5,500 RPM, it was probably for 1.5 seconds. Keep in mind, points and condensers are not variable dwell any either. How many millions of people have gone drag racing with points and condensers? So the upshot here is most Duraspark conversion users, they're not drag or road racing, they're street cars. So this is just kind of helpful. Okay, how do we measure voltage at the coil? Now, a lot of confusion on the blogosphere. People will try to do this with the engine running, and you really can't. So don't bother. Now, it's very easy though. Remove the negative wire from the coil, including the high tension coil wire. Some people will say you can keep the high tension wire. I usually don't bother. Take it off. Keep the positive wire on there because that's where the voltage is going to come from. So you remove the negative wire, right? Take a clip lead and send that directly to the battery negative ground. Don't send it to the chassis. Go right to the battery and get a rock solid negative ground. Now you put the ignition key in the run position, not all the way to the crank position, just the run. Engine's off, of course, right? Now you measure the voltage at the positive side of the positive terminal of the coil. So because of the total ballast resistance value, the wire plus the coil's primary resistance, that's where you're going to see this voltage knockdown. It's probably around 7 to 8.5, depending on the total ballast resistance. This is an actual measurement I did here. It's actually around 7 scales off here, so it's 7.4. Okay, if you get a really high voltage, like 11 volts, that's near battery voltage, somebody probably deleted your pink ballast resistance wire, and the only resistance you have is coil. So if you have a low primary resistance coil like 0.6, 0.7 ohm, you might get something close to battery voltage. If you get a really low value, somebody may have added a ballast resistor in combination with the pink ballast resistor and maybe a high primary resistance coil. So that would be cause to investigate what really happened there. Okay, now it's getting exciting. We're going to talk about Duraspark coils. Basically, they're inductive ignition coils. Most coils nowadays are not inductive. They're CDI, capacitive discharge coils, but they still make plenty of induction ignition coils. And that's what we're going to use for Duraspark because that's what it's intended to use. Now, what is an inductive ignition coil? How do I know when I'm getting them? Sometimes they'll say it in the advertisement, but sometimes they'll say both inductive and CDI, and you're like, well, which one is it? Okay, so in inductive ignition coils, Duraspark should have those with these approximate values. They should have long spark duration. You can see the values here. I won't repeat them. High voltage, high peak current, and a turns ratio of 100 to 1 or lower, not higher. Got a couple important notes. CDI ignition coils. A lot of people are just going to say, man, I love that bright red MSD blaster coil. Is it going to work? It will work. It's got a pretty low spark duration compared to an inductive coil. So some people with Durasparks, they've read things on the blogosphere and said the real trick is to get a TFI coil. Again, that's going to work, but that even has a lower spark duration. The peak current is very good though. Look in the intro screen. You'll see technical articles linked about ignition coils. So I won't go through some of these more boring notes, but for ignition coil nerds, which I have a lot of respect for, you can check that out and drop a comment if you have an opinion. So for a high or higher performance Duraspark usage, we're pretty much looking for a primary coil resistance with similar or lower than stock Duraspark. Keep in mind, the Duraspark II coils were already lower than stock 65, 66. You can see the difference. That's a fair difference. So this lower total ballast resistance is going to increase coil voltage. But as this presentation discusses, we need to ensure that the total system amperage is not high enough to damage the module, and we need to pay attention to coil heat. So daily driver performance, you can use a primary coil resistance similar or lower than stock Duraspark, and we will be seeing the coil comparative data coming right up. Okay, here are the Duraspark compatible coils that I thought we should talk about. Now, all coils listed are inductive types, and they are compatible with the Duraspark Blue Grommet module. Every single one of these we're going to talk about specifically. Now, where did these coil voltage values come from? They are with the key on, engine off. Now, coil voltages for each one of these combinations, I mathematically extrapolated them from some actual measurements that either I did, my friends did, or got from the blogosphere. It's impossible for me to actually have actual measured voltage on each combination. Some of you are rolling your eyes and saying, oh, I can't believe he did math and made up numbers. They're not made up. They're extrapolated from the resistance from the coil and the wire. So if you want to know what your actual values are here, go do your own voltage calculation, your voltage measurement, recompute, and then you will know. This is not an inclusive list of all possible Duraspark compatible coils. Any inductive type ignition coil with similar specs should work. Let's talk about these one at a time. Okay, I mentioned in the intro, I ran this coil with my first Duraspark setup. So what I'm going to do for each one of these coils, you'll see the factory specifications. Okay, so you're going to see the factory system amps, and you're going to see the system heat, which we're just going to assume is all at the coil, and then we're going to compare to the aftermarket one here. So what we're seeing here is for this Accel coil, the system amperage is only slightly higher than the stock Ford points and condenser, including the coil wattage. That's why I use this coil and did not have a problem. A lot of people in high school would use this with points and condenser. There's a reason Accel made this 1.4 ohms. That's very close to factory primary coil resistance. It's got good voltage output, good turns ratio. Millions of these have been sold. They used to be made in the United States. I used this in high school on my 72 Ranchero with a 351 Cleveland, and it worked great. This is an old school inductive style coil. It's going to work. There's probably better ones. Well, there are. But if you've already got this one or you want to get it, you're not going to have a problem with the Duraspark conversion. Okay, I mentioned in the intro that I upgraded to this one. Now, I did this, let's look at the total system amps. Now we're up to 4.2. That's a big jump. I ran this thing for 2 years with the Wells Amco solid state aftermarket Duraspark module. If I'd use an NOS module, I don't know if how long that would have lasted. Maybe it would have lasted a long time, but I've gone to 4.2 amps with this. The coil heats a lot more, but this is a tank. Again, millions of these coils have been sold. I used this for 2 years, never had a problem. Low primary resistance. It did come with a ballast resistor, but I didn't use it. We're talking about that on the next one. Voltage is excellent. You'll notice the turns ratio is 70 to 1, a lot less than 100 to 1. This coil was great with a 40 thousandths gap. This was a noticeable improvement in performance with this coil. I miss these coils. Okay, so let's go. Some of you are going, oh my God, I remember this thing. Yes, this thing, the ProMaster, this thing is still around. Now, unlike the Accel Supercoil, the ProMaster did not come with a ballast resistor. So before we talk about Duraspark, let's talk about all the kids in high school, if you're around my age, who would buy these things. Remember Super Shops? They would buy this thing at Super Shops, bolt this on, and they would kill their points and condensers. Sometimes 3 or 4 blocks down the road. Now they're stranded on the side of the road and it's pushing it back to mom and dad's garage. So this has got a really low primary resistance. If you put this on a points and condenser system without adding a ballast resistor, you're likely going to fry your condenser. So for Duraspark, is this going to work? I think it would. Look at the system amps. It's about 4.5. The watts is high, it's about double, but this thing's a tank. This is a great coil. If you want that old school look, this is a great coil. If you've already got one, it's not too old. I think these are oil filled, so don't turn them sideways and drain the oil out. But look at the voltage on this thing. And turns ratio, peak current, spark duration, it's really good. Some of those earlier coils I mentioned, those are really old coils and they don't have these specs. I poked around, you just can't find them. It doesn't mean that the original engineers don't know them, they've just never published them. This one they did. Now let's talk about a more modern one. Okay, this coil is the bad dog. And look what it says, inductive, Chevy HEI. Look at this, Ford Duraspark. This is the coil to use if you're like, I wish this guy would shut up and just tell me what coil to use. This is a bit of a tank under the hood, but compared to like a round coil. but this is your coil. Look at these specifications. Look at the maximum volt here. It's almost 62,000. Primary resistance 0.9. Excellent peak current and spark duration. As I mentioned earlier, this is an inductive coil for inductive ignition systems. They did this on purpose. If you just want to have a coil you know is going to work, this is it. Look at the system amps here. It's not much higher than stock. System watts is nothing. This is a epoxy filled coil, so you can mount it in any position. It's made in the United States. If you want the best for your Duraspark, get this and you are not going to have a problem. Okay, now let's get Pertronix out of the way because people are thinking Pertronix is the ones that have got it figured out. Pertronix all the way. You can do that. That's fine. This is the conservative coil for Duraspark. Why is it conservative? It's 1.5 ohms. So look at the system amps. It's actually lower than factory, including the system heat. If you've got a Duraspark setup, you've already got this coil, and you just want the most conservative system you can get. What's the definition of conservative? I don't want to be stranded on the side of the road. I don't want to. I want the thing to run, and I don't want to have to worry about coil overheating or module failures. This is probably your most conservative coil. The specs are good. This is a good coil. You're not going to have a problem with this. Here's some more information on the Pertronix. You can see they're saying open up the gap. That's a good idea. Okay, here's the other Pertronix. This is the one if you like Pertronix, and I like Pertronix. This is the one I think you would run with a Duraspark. A lot less primary resistance, 0.6, more voltage, turns ratio is spot on. This is really an inductive ignition coil. They say can be used with CDI. They want to sell parts, but these specifications, guys, this is an inductive ignition coil. This is going to work great with a Duraspark setup. You're about here in about the mid 4s on the system amps. You've doubled the wattage, but this modern coil, it can take it. You can get oil or you can get epoxy. I would just get the epoxy one. I'd bolt this on. You're finished. This is a good coil. Okay, why is this in here? Some people are like, I want to use this stock horseshoe type Duraspark connector. Well, you're stuck. There's only a couple ignition coils that use this, the little spade terminals that are compatible with this. The NGK, there's no specifications on this, guys. Is it going to work? Oh, sure, it's going to work, but is this high performance? I don't think so. It's adequate. Same thing with the Blue Streak. These are the only two I know about other than stock Ford that you may find on eBay. I wouldn't bother with one of those anyway. Okay, those of you that have not died from boredom yet, suffering insomnia, where did I get all my schematic information? I got it from the factory wire diagram for starting and charging. Let's get into that specifically. Okay, I've got a full video on my channel about start and ignition for 6566. I go through it painstakingly. So I'm going to rip off some of those slides here before we see the conversion. Okay, I won't go through every wire here like I did in my other video, but that factory pink resistance wire, you see what I mean? That's not under the hood. That's under the dash. Remember that bullet connector I mentioned? This is it. That's how simple it is to find this thing. You're going to tap into here, and let's get into that. Okay, this is the simplest Duraspark II. What does he mean by simple? It's no tack, no crank retard. We'll look at all of those though. As I mentioned, Duraspark module is full 12 volts. That's why you don't have me doing under hood work showing you install this. It's too simple. You go under your dash, you find this pink wire, pull out the bullet. That's it. Make a little jumper harness right here. Jump the 12 volts to the Duraspark module, and then have the other end of the harness go right through that pink resistance wire. You're finished. The other wires go directly to the Duraspark module, which is grounded. People think, do I have to ground this Duraspark module? No, it's internally grounded. The green wire goes the negative side of the coil. That's it. That's why you don't need to watch these goofballs doing this on YouTube. This is it. Ford guys can do simple wiring. You can do it. This is all you need to know. Let's get a little bit more complicated. Okay, the crank retard. What's up with that crank retard? Is that a real thing? It is a real thing. So it's about 4 degrees. So if you're running Duraspark with maybe a high compression engine, you can get a 4-degree wire crank retard. So that's the white wire. You probably don't need this. I never used it, but it'll come off the I side of the solenoid. It can also come off the S side. They're both intermittent. So during cranking, 4-degree crank retard. You can look at the intro screen for sources for Duraspark, because some of you are saying, where the heck did he get the 4 degrees? So that's it. So let's look at one with a tach. Okay, pretty easy. I have not shown the crank retard. This is an aftermarket 3-wire negative triggered tach. We will talk about problems with factory Ford tachometers, which are positive trigger tachometers. Those are a pain, and we'll have some dedicated slides on those. So let's look at the full meal deal. This is everything. There's the tach, crank retard. You see how easy this is? This can't be easier. So we will talk about people's problems with the conversion. We already talked about the max system amperage, coil heat. We'll also talk about the distributor and the drive gear, because people will have problems with those too. But you see how easy this is? Not that hard at all. Just go under the dash, find the bullet, get your power. Okay, now you are Duraspark conversion experts. So why is this a problem? Most people don't seek out information like this. They go to their favorite spot, the blogosphere. The blogosphere is garbage. Even people who think, well, I have good sources on various stuff. I love this guy, Mustang Steve. We all do. This is highly problematic. Am I picking on him? I'm not trying to pick on him. There's literally dozens, if not hundreds, of garbage blogosphere Duraspark conversion diagrams. This is indicative of problematic ones. You notice how he's disconnected the pink wire? He just says 12-volt high performance coil. What the heck is that? Okay, you've seen all the calculations. So he's disconnected the pink resistance wire. So the resistance wire is zeroed out here. So let's do the calculations. Let's assume he used that Pertronix 1.5 ohm coil, the one we talked about earlier. What's his max system amperage? About 5.7. Is a modern DY893 Ford module going to tolerate that? Probably. Coil heats a lot. Those of you that remember incandescent light bulbs, would you reach out with your hand and grab a 50-watt light bulb? I probably wouldn't. I sure wouldn't do a 108-watt light bulb. So let's say you don't use a 1.5 ohm, use a 0.6 or 0.7 ohm coil. Look at your system amps here, 12.4. If you fire up a Motorcraft DY893 with that much amps and that thing works for years, leave a comment if you did this. Maybe the Ford module can do that. That's a lot of amperage. Look at the coil heat. Okay, maybe at Pertronix 0.6 going to be higher with 0.6. I just used 0.7. It's going to be higher than 108. Maybe a modern epoxy can take that. If you're doing this and it's working, drop a comment. So I kind of articulated this stuff. I would not do this here. This is too much. And if I did it, boy, I'd have a spare in the trunk. Okay, fault isolation and troubleshooting. Let's go through this word for word now. Let's spare you. Let's go through the common ones here. Okay, common one, especially from the blogosphere. It sometimes starts, sometimes quits, gives poor performance. People do not understand that pink ballast resistance wiring, and they will route power to the module through that pink ballast resistance wire, and the car starts up and they think, oh, the Duraspark doesn't care about that knockdown. We don't know the Duraspark's internal resistance, so we don't know what the voltage knockdown is. So the Ford instructions say to route the red wire full 12 volts. Don't do this. If you do this, you may have these problems. Module failures, that's the biggest complaint. Probably insufficient total ballast resistance, leading to module damage from over amperage. That's probably the #1 cause. Coil overheat and or failure. Use the calculations that we talked about in this presentation, and you'll know what the coil heat is, and if they're getting super hot and failing, then it's a ballast resistance system issue. Okay, poor performance tach readout problems. So some of you are going, what is he talking about? The Duraspark's not routed through the tach. Yeah, okay, I understand that. So we're going to have dedicated slides here in the tach. Stand by. The factory, if you have like a Mustang with a factory tach or a later Ford with a factory tach, hey, I'm jealous. Those things are cool, but they are not negative trigger tachs. They're positive triggers. So they route the ignition, the 12 volt to the coil, they route it through the tach. So if that tach starts to get flaky, come on, they're 50 plus years old. If that tach starts to get flaky, the signal to the positive side of the coil is getting flaky. So you really need to convert the tach to modern 3-wire operation, which we'll talk about. Okay, Duraspark distributor gear, excessive wear. Yeah, if you use a cast iron distributor gear on an old Ford steel cam, that's not going to last long. We got dedicated slides on gears, so we'll talk about that. So poor spark performance, too much ballast resistance. I've seen this once. A buddy of mine kind of accidentally did this. I won't get onto it. So he used a ballast wire plus a ballast resistance plus high primary resistance coil. Yeah, it'll run, but yeah, poor performance here. Just don't do that. Okay, we talked about the tachs. This guy, what is he talking about? Ford didn't do that with the tachs. Yes, they did. And here it is right here. It's a positive trigger system. I think Ford did it to save wire count. Who cares? That's what they did. So you can convert these to 3-wire operation. On the next page, we will look at the sources that do that. Some of you may say, well, my car is Concours correct and I can't do that. If you've got a Concours correct Mustang with a tach, you should not be watching Duraspark conversion video. So these are the 3 places that do it. They'll convert any Ford 3-wire to any Ford positive trigger tach to conventional 3-wire negative trigger operation. Go ahead and do that, and you've maintained your factory tachometer, which is cool. Okay, distributor gear wear, the bane of Ford users. Okay, it's not as bad as it seems. There are multiple reasons for distributor gear failure. I've got a video on camshaft end play where I talk about that a lot, but we'll just talk about material capability or compatibility. I've got a hyperlinked article that talks about materials at length. You can check that out. Here's a screenshot. These melonized gears are really the way to go if you're rolling your eyes and saying, would you just tell me what to use? Just go get the melonized drive gear and let's talk about it some more. Okay, now I mentioned there are several reasons here. One is a high volume pump. I've got a video on that. You can watch that if you want. You don't really need to use a high volume pump. It's not the primary reason for wearing out a gear, but it can definitely contribute to it. I've got a video on camshaft end play. Gear placement on the shaft is extremely critical on a Ford. Local machine shops often can't do it. Well, I don't need a local machine shop. I have a Harbor Freight press. Okay, look at this range. It's very tight to get that in there. I have a distributor made by Davis Unified Ignition Performance Distributors. They know how to do this. So let's talk about materials. Okay, now a lot of you are running comp cams. Some people will run a comp cam and then they'll use the stock steel drive gear on their distributor because they have like a 5.0 that had that gear. You are risking kissing off your expensive comp cams camshaft if you run a steel gear, a steel distributor gear on a comp cam, these ADI cams, tempered ducktail iron. People are going to watch this going, well, I've been doing it for years, never had a problem. Good. I'm not saying it's going to happen every time, but there is a reason why these materials are different, and there's a reason why these melonized gears are available. So the comp tempered iron ones, these Addies, they have a -8. You can see this article I've got hyperlinked. We recommend an upgrade to a Melonized style gear. It's not absolutely necessary. I like de-risking my aftermarket projects. So you want to de-risk it and you're putting a distributor in anyway, have performance distributors make you a custom curve distributor, a Duraspark for your Ford. Tell them to put a Melonized drive gear on it like I did. You need a drive gear anyway, and you are going to de-risk gear compatibility. Okay, thank God we're almost done. So is this Duraspark thing really a trip down memory lane? Pretty much. So should you convert to Duraspark? I would say yes, but only if you're trying to do the following. Are you trying to do something simple, economic, non-intrusive? You put the MSD or something under the hood. You got the box and the wires. I have MSD on my '69 Mustang, so it depends on what your intended function is. If you want something that's mostly Ford, yeah, use the Duraspark with that DY893 module. Now, I mentioned, let's talk about performance. They're not variable dwell. Will they work for drag racing? How many people have gone drag racing with Duraspark? Thousands. They'll work, but they're not optimum for high RPM sustained operations any more than the points and condensers were, which are not variable dwell. Well, not electronically variable, but you know what I mean. Now, if you're going to do this, duplicate the Ford Duraspark combined ballast resistance setup, which means the wire plus the coil, dissipate the heat, use the Motorcraft DY893. Use the calculations in here, which is basically the resistance wire and the coil, primary resistance. Keep the system amperage below 6. If you keep it below 5, that thing's probably going to last forever. Use a high performance coil with at least 40,000. Open up the spark plug gap. A lot of people forget to do that. Use a custom curve distributor for high performance applications. Some of you may be thinking, I don't want one of these stupid old Duraspark distributors. I'm going to get this Mallory ball bearing distributor that has the magnetic trigger because the magnetic trigger will work with Duraspark. It will. Those are $500 distributors. Maybe if they were $250 or $199.95, but call up Davis. Performance Distributors used to be called Davis Unified Ignitions. Fill out their form, give them the specs on your car, get a rebuilt Duraspark distributor from them with a Melonized drive gear. You're not going to have a problem. And you're going to have simple, effective, long life ignition. Take your made in China spare module, toss it in the trunk.